Hey everybody, it's Mr. Carr again. Today we're going to be talking about 7-6, common logarithms. Okay, so you actually have a button on your calculator that does logs. It does one specific log though. If you see log, that is the same as log base 10. Okay, so that's what we're looking at here. If you use a calculator, you evaluate log of 6. All right, technically speaking, what that's doing is log base 10 of 6. So if you do this, you hit log 6, enter, you get this decimal number. So you can round it off to this. So again, what this means is 10 raised to the 0.7782 should be about 6. Okay, so that's something you can try on your own and make sure to like kind of go back and forth and double check. If you do log of 6, that comes out to this. If you take 10 raised to that exponent, it should come back to that 6 number. So how can we use that? The goal with that one is if we're doing stuff with this part right here. Back in 7.2, we said if you are able to rewrite each side of the equation with the same base number, then you can set the exponents equal to solve. So this was an example of that. So 2 to the x minus 1 here is equal to 8. 8's the same as 2 to the third power. So that means we know that these two things have to be equal. So we just solve this equation, 3 equals x minus 1. Now, you're going to encounter equations where we cannot write each side with the same base. In this case, we must take the log of each side of the equation and then use the properties of logarithms to solve. So this is what we mean by that. So solve 5 raised to the x plus 3 equals 62, and then round to the nearest 10,000. Okay, so normally like I said, this would be a case where if we could rewrite 62 in the base 5, then it makes it a lot easier. We cannot do that though. So we can do 5. I'm just going to rewrite it again here. Okay. So, sorry, give me 1 second. Okay. So in this case, if I can say this right here is true, that means if I take log of 5x plus 5, the log of 5 raised to the x plus 3 power equals log of 62. So from here, we know that we can take this right here as an exponent and rewrite it in the front. So that means x plus 3 times the log of 5 equals log of 62. Okay. From there, we want to isolate x. So I'm going to divide both sides by log of 5. So when I do that, I'm going to get rid of that. So x plus 3 is equal to log 62 over log of 5. And my final step is to subtract 3 to both sides. Okay, so right now I'm leaving everything in terms of logarithm, but I'm going to go ahead and put this in my calculator to get the actual number. So, whoops. So x is equal to the log of 62 divided by the log of 5 minus 3. So this is what goes in my calculator, and I'm going to round it to the 10,000th. Okay, so I can do, and again, this is any scientific calculator has logarithms on them. Just got to find that button. So log of 62 divided by log of 5, and then subtract 3. And x comes out as a negative 0.43, tenths, hundreds, thousands, 10,000, so 4 decimal places. So negative 0.4357. Okay, so that's how I get to that. And again, if you want, you can take that, plug it back in here and double check. Okay, so 5 raised to about 2.5 power, almost 2.6, right around there. That should come back out to 62 is the idea. All right. So we got 3 to the 2x equals 6 to the x plus 1. And again, we're going to round to the nearest, well, in this case, 10,000. Yeah, no, 10,000. Yeah, 10,000 again. So I can rewrite this as log of 3 to the x. Sorry about that. 3 to the 2x equals log of 6 to the x plus 1. Again, these are exponents, so they can come to the front like this. So 2x times log of 3 is equal to x plus 1 times the log of 6. All right. From here, I would personally, let's see here. So it's going to be a fun one to work with, but if I divide by x plus 1 here, divide by x plus 1, but also divide by log 3. Okay, so that will cancel out, and then that will cancel out. I'm going to be left with 2x over x plus 1 equals log of 6 divided by log of 3. I don't know if that really, honestly, that didn't really change a whole lot for what I'm doing here. Probably just going to have to deal with, well, let's see here. Log of 6 divided by log of 3, let's get that as a number. So if I do log of 6 divided by log of 3, that comes out to 1.630. Let's go with 9 for now. Okay, so that's what that part is. Put that over 1 and now do my cross multiplication. Doesn't look like a very easy one, but I'm going to keep my calculator with that 1.6309. So I'm not technically rounding to the very end. Okay, so I'll have 2x is equal to 1.6309 plus, or sorry, x plus 1.6309. That's me taking this number and distributing with x plus 1. Okay, so now I could subtract that one over. Okay. So that's gone. So I've got 0.369 equals 1.6309, and then I divide both sides by the 0.3691. Again, I'm using the numbers in the calculator, so I'm not actually rounding off here. Okay, so get that divided by, sorry, give me 1 second here. I'm going to use a slightly different calculator. Okay, sorry. I know this is fascinating as I put my calculator work in here. Okay, so that's going to give me this, and then divided by 2 minus that one. Oh, okay. All right, and that comes out to 4.4190 for the nearest 10,000. Okay, so this leads us into the change of base formula. Okay, so when doing the change of base formula, this is what we can use with our common logarithms. So for all positive numbers, a, b, and n, where a is not equal to 1, b is not equal to 1, it looks like this. Log base a of n is the same as taking log base b of n over log base b of a. So n is going to go on top, a is going to go on the bottom. So how we can use this with our common logarithms, if I'm evaluating log base 3 of 11, that's the same as taking log base 10 of 11 divided by log base 10 of 3, which is the same as log of 11 over log of 3. That might make things a little bit easier when we look at the change of base formula like this. So with this example, just real quickly, we're going to apply that, express log base 5 of 140 in terms of common logarithms, and then round to the nearest 10,000. So log base 5 of 140 is the same as the log of 140 divided by the log of 5. So that's why I plug in my calculator. Log of 140 divided by log of 5. So log of 140 divided by the log of 5. So when I do that, I get 3.0704. Okay. And again, what that means is 5 raised to the 3.0704 should come out to 140. Okay, so 3.0704. Yep, pretty much 140 there. All right, so that's our last part, is just the change of base formula. That you'll see some on some of the homework problems. It might be easier to use that idea for solving our purposes here. Okay, but that's it for now. And that's it for 7-6. All right, remember, change of base formula, as well as solving with our common logarithms. They get a little complicated, but still doable. All right, take care, everybody.